In this section, we're going to dive even further into the concept of graphing and derivatives and what derivatives can tell us about a graph and vice versa. And so specifically, I just want to reiterate points number 1 and 2 on here that hopefully y'all have already looked at. But basically, it just says that if your first derivative right here is positive, it's greater than 0, then obviously your main function f has to be increasing. And that makes sense because if the derivative is positive, that means you have a positive slope. And positive slope is just always increasing from left to right. Okay, and then part 2 is that just says that if your derivative is less than 0, so if your derivative is negative, then your main function has to be decreasing over that same interval. Okay, so a positive derivative means a positive slope going up, a negative derivative means a negative slope and going down. And then other than that, just the point I want to really iterate more than anything is just this first derivative test. Basically all it does is test to figure out where it's going to be changing, and where those are specific points where the graph goes from a negative derivative to a positive derivative. So obviously there was a special extrema that happened there, whether it was a maximum or was a minimum. So if your derivative goes from negative to positive, if it goes from a downward slope to an upward slope, then therefore you had to have a min. And if it went from positive to negative, then you had an upward slope, a downward slope, and it went from obviously having a local max. So let's take these thoughts and let's go to example 1. Here in example 1, we're already given the derivative. We know that f prime of x is equal to x minus 7 times x plus 1 times x plus 5. We want to find the critical points, the intervals of increasing, decreasing, and the points where the local maxes occur, if any. Okay? Well, the first thing that we want to look at is the fact of finding the critical points. Remember, the critical points occur by definition is where your first derivative is either equal to 0 or it's undefined. Well, here's our first derivative, so let's set it equal to 0. And then, just because it's already factored, solving this out, that gives us potential x values of 7, negative 1, and negative 5. So here are our potential critical values. So now from here, if we want to find the intervals of increasing and decreasing, what I'm going to do is put these points on a number line. So negative 5, negative 1, and 7. And I want to do is I want to see what's happening around these points. And specifically, I want to know what the slopes are. So I'm going to go back to our first derivative function, and I'm going to plug in values to the left, in between, and to the right of all these points. So a value to the left of, let's say, of negative 5, let's test x equals negative 6. And then in between negative 5 and negative 1, let's just test x equals negative 2. How about x equals 0 and x equals 8? Okay. And all I want to do when I test these, I don't need exactly an exact number. I just need to know if it's positive or negative. If it's going to come out positive or negative. Okay. So let's kind of think. If I plug in negative 6 into the first parentheses, negative 6 in that first parentheses would give you a negative 13, so that's obviously negative. That would be a negative right there. And negative 6 plus 5 is also a negative. So 3 negatives make an overall negative. So again, not really worried about the magnitude, just trying to figure out exactly if the sign would be positive or negative. Okay, so let me erase those. Let's go to our next point. We want to test there at negative 2. So if I plug in negative 2 in this first one, we'll get negative 9, which is obviously negative. Negative 2 plus 1 is negative. And negative 2 plus 5 is positive. So negative, negative, positive is actually positive. Okay. Testing x equals 0. That'll give us a negative for the first one. It'll give us, let's see, 0, so positive and positive. So a negative times a positive obviously will come out negative. And lastly, let's test x equals 8. So at 8, we'll get a positive right there finally, a positive, and a positive. So 3 positives make a positive. Okay, now because what I did is I tested this in our derivative, these are telling us what the slopes are doing. So this is right here is a negative slope. This is a positive slope. This is a negative slope and a positive slope. If I want to draw a picture, a negative slope means the graph is going down, the main function. Positive slope says the graph's going up, then down, and then up. Okay, so to answer the question, the intervals of increasing. Okay. We're looking for all those positives up there because obviously that's where the graph is going up. Well, it starts increasing from -5 and then stops at -1, and then it goes back increasing at 7, and then since that's our last potential critical point right there, then it's going to go off to infinity. Okay, and notice I'm going to put parentheses with all these. I don't want to brackets because I don't want to exactly equal the critical points. Because at the critical points, technically your graph is flat, so you can't be increasing or decreasing. Okay. And then the intervals of decreasing. So obviously, starting here on the left, the last thing we have is down, so it's going negative, and it starts actually at negative infinity and goes up to -5, and then again at -1 up to 7. Okay, so to answer the last little bit, we want to see if there are any local maxes or if there are any local mins. Okay, remember a max occurs when your graph goes from increasing to decreasing. Okay, so let's analyze real quick. Let's focus on 5, x equals 5. To the left of it, I'm going down. To the right of it, I'm going up. So if I go from down to up, that means I had to have a local min. So there would be x equals -5. Okay, and then going beyond that, let's go to -1 for our critical point. To the left, I was going up, so my graph was increasing, and then it hit that and went down on the right. So it goes from increasing on the left to decreasing on the right. So we had a local max then at x equals -1. And then 7, last but not least, we go from decreasing on the left to increasing on the right, down to up. So then that's going to be another local min at x equals 7. Okay, so basically all of our answers are just the intervals of increasing, decreasing, the listing out the local max and mins. And so I guess the last thing, if we want to just actually state it out, that our critical points were x equals -5, -1, and 7. Okay, let's go on to the next problem. So for this function right here, specifically from 0 to 2 pi, let's find the critical points, the intervals of increasing and decreasing, and the points where the maxes or mins occur. So to get started, again, we want to find the critical points. So the way to find the critical points is we're going to set our derivative equal to 0. We have sine x plus cosine x and sine x minus cosine x. And since it's factored, then we're saying sine x plus cosine x equals 0 and sine x minus cosine x equals 0. Okay, well, finish solving this out. It's basically saying sine x is equal to negative cosine x and sine x equal to positive cosine x. Okay, so interpreting this, it's basically saying in one full revolution of our circle, so one time around, when are my y values equal to the opposite of the x values? Okay, so the y value is equal to the opposite of the x values. That can only happen in quadrant 2 because the x values there are negative and the opposite of negative is positive, and in quadrant 2 the y values are positive. And then also in quadrant 4, because in quadrant 4 the x values are positive, but the opposite of positive is negative, and the y values down there are negative. So there's quadrant 1 and 4 for those. And then when exactly are the y values equal to the x values as is? And that's going to be quadrants 1 and quadrants 3, because in quadrant 1 they're both positive, and in quadrant 3 they're both negative. So in the first, that means that x has to equal in both cases. The only time when they're equal is right there at pi over 4 or 45 degrees, because they're both values are the square root of 2 over 2. So in quadrant 2, or I guess let's go in order, quadrant 1 then would be pi over 4. Pretty much just going to list all the pi over 4s in quadrants 1, 2, 3, and 4. So 1 and then 3 pi over 4, and then 5 pi over 4, and then 7 pi over 4. So if we want to start right here, here are my critical points right there, all 4 of those values. And like what we did before, we're going to take these values right here, and we're going to test them in the derivative to determine what our signs are doing, what our slope's doing. Are our slopes increasing or are they decreasing? Okay, so listing them in order, here's pi over 4, and then 3 pi over 4, 5 pi over 4, and then 7 pi over 4. Okay, so if we want to test something to the left of pi over 4, which obviously is 0. If we want to test something between pi over 4 and 3 pi over 4, something nice and easy, we might test something like pi over 2. And then how about between 3 pi over 4 and 5 pi over 4? Let's just test pi. 5 pi over 4 to 7 pi over 4, let's do 3 pi over 2. And then how about there, just 2 pi. Okay, so we're going to go back to our derivative and plug these in and see what the signs are going to come out to be. So at 0, the y value at 0 is 0. The y value there is 1. Okay, so far right there, that parentheses is obviously positive. And then here, the y value at 0 degrees or 0 radians is 0. And the x value there, this is going to be x minus 1. So a negative. So positive times a negative would be negative. Okay, let's keep on tested. Let's go to the next one. At pi over 2. Okay, so the y value at pi over 2 is 1. The x value is 0, so overall it's positive. The y value at pi over 2 is 1, and then minus 0, so it's positive overall. So the positive times a positive is a positive. Okay, next one we want to check. Let's go with pi. The y value at pi is 0. The x value at pi is negative 1, so overall it's negative. And the y value at pi again is 0, then minus a negative 1, so that's positive. A negative times a positive is a negative. Right now they're alternating in signs, but you know what? You know, see how it's going negative, positive, negative. I bet you the next one's positive, but I don't trust myself. I would like to check just in case. So 3 pi over 2. The y value down there is negative 1. The x value is 0 and negative 1. So a negative 1 and a negative in this parentheses, a negative in that parentheses, overall positive. Okay, and last but not least, let's test 2 pi. And 2 pi, since 2 pi is the same thing as 0, isn't it? Whether you start at 0, you go start at 2 pi, you're landing right back at the same spot, so it's going to come out overall negative right there. So the intervals of decreasing are going to be from negative infinity up to pi over 4. Again, union 3 pi over 4 to 5 pi over 4. And then one more time, looks like it's starting at 7 pi over 4 and going off to infinity. The intervals of increasing, all the positives. So we're going from pi over 4 to 3 pi over 4. And just one other time. So 5 pi over 4 to 7 pi over 4. Okay, and you see what's happening is it's just basically, this is just labeling off what the main function's doing. Okay, we're using the slopes to determine what the main function is. So these are intervals on when the main function's decreasing and the main function's increasing. Okay, and last but not least, before we start the next problem, let's find our local maxes. Okay, so max is when we go from increasing to decreasing. Okay, and then we want to find our local mins. I kind of like to go in order and just plop them down. So here, let's look at pi over 4. Left, so I'm going down on the left, up on the right, so that is a min. Okay, 3 pi over 4, I'm going from up on the left to down on the right, so there was a max there. Okay, 5 pi over 4, down on the left, decreasing on the left, increasing up on the right, so it's a min. And going from increasing on the left to decreasing on the right, that will be a max. All right, on to the next problem.